Hello everyone, myself Vishwadeja. Today I am going to discuss about the operating systems project 1. In this project, we are going to discuss the Nand to Tetris. Basically, in Nand to Tetris, we have two parts. First part is hardware platform, where we have computer architecture, CPU, RAM, chipset, and elementary logic gates, which will combinedly form a basic electrical engineering project. Then second, we have software hierarchy, where the human code will be executed by converting the high level program to low level program and then transferred to the compilers. In this video, today's objectives are we are going to discuss about the hack computer, Boolean logic, logic gates, NAND gate, HDL, and hardware simulator tool and project one simulations. Now, first is hack computer. Hack computer is known as general purpose computer that runs any program. Hack computer mainly or basically consists of RAM, CPU, RAM, and ROM. RAM and CPU both are connected bidirectionally. That is, RAM can share the information to CPU and CPU can share the information to ROM. Hack computer. So the basic idea about the hack computer is computer that can run any program. Next, we are going to discuss the Boolean logic. Here we are going to discuss about the Boolean values, which are basically 0 or 1, true or false. Then Boolean operations like and, or, not, etc. Then comes to Boolean function, then identities, which are various laws of Boolean values. Now, Boolean values. We know that 0 and 1 are known as Boolean numbers. Boolean values can be of the form F or T, that is false, true, no, as 0 and 1. Basically, false is represented as 0, true is represented as 1. Boolean operations. The basic Boolean operations are and, or, and not. Apart from these, we have so many Boolean operations like NAND, NOR, XOR, etc. But today we are going to discuss about the and or not in detail. Here is the representation of and or and not. Not is basically known as a negation gate. That means when we input the symbol 0, we'll get the output as 1. When we input the symbol 1, we'll get the output as 0. Either the AND gate. AND gate, when both the inputs are 1, we'll get 1 as output. But in OR gate, when both the inputs are 0, we'll get 0 as the output. Now, coming to Boolean functions. Any Boolean expression can be represented using an expression containing AND or not operations. These are the three elementary operations. We can express the Boolean functions in two ways. First is the expression way or known as formula way. The second is the truth table. Truth table is the most convenient way to represent the Boolean function. Now, Boolean functions is a truth table representation. Here, x, y, and z are known as Boolean values, and f is a Boolean function. Boolean function, it is represented using the formula. Here, x, y, and z are known as Boolean values, and this is a representation of Boolean function. And it is a truth table representation. Now, Boolean identities. There are various Boolean identities like commutative law, associative law, distributive law, and De Morgan's law. Here, very important is the De Morgan's law. We are discussing about this law now. Commutative law. X and y is equal to y and x. That is opposite. Or x or y is equal to y or x. This is known as commutative law. Next, associative law. X and y and z is equal to x and y and z. X or y or z is equal to x or y or z. X and y or z is equal to x and y or x and z. X or y and z is equal to x or y and x or z. These are known as distributive law. Now coming to De Morgan's law, which is a very important law and very useful for our examination purpose. That is not of x and y is equal to not of x or not of y. Not of x or y is equal to not of x and not of y. These are the Boolean entities. So it is very important to remember all these four Boolean entities. That is commutative law, associative law, distributive law, and De Morgan's law. Next, going to logic gates. What do you mean by logic gates? It's a technique for implementing the Boolean function. There are basically two types of logic gates: elementary logic gates and composite logic gates. Basically, elementary logic gates are the basic gates like NAND, NOR, AND, OR, etc. These are ready to implement the gates. But composite gates are the gates which are derived from the elementary gates, like mux, demux, adder, etc. That is, composite gates are derived by adding two or more elementary gates. Now we discuss about the elementary gates. And or and not are the basic elementary gates. Here for and or we have two inputs and one output. but for NOT, we have only one input and one output. Here it is given that in and NOR, if the input is equal to 1 for both the input values, then we'll get output 1, else it is 0. But for NOT, we'll get input inverse. That is, if we input 0, we'll get 1. If we input 1, we'll get 0. There's an inverse operation. There is one of the most important elementary gates that is known as the NAND gate. NAND gate, we have two input symbols, A and B, and we'll get only one output. It is also known as universal gate. Why it is known as universal gate, we'll discuss in the video. Composite gates. We already discussed that composite gates is the combination of elementary gates like mux, demux, etc. Here is the representation of composite gates. When AND gate for three variables, it is a composite gate, mux gate, and demux gate and representation. As I told you, NAND is known as universal gate. Why it is so? As a Boolean function can be represented using an expression containing only NAND gates. That is, any expression of AND or NOT gates can be represented only using NAND gate. Here is a truth table for the NAND gate, and x NAND y is equal to NOT of A and Y. These are the representation of NAND gate. NOT of x can be represented as x NAND x, and x and y can be represented as NOT of x NAND y. Next is the diagrammatic representation of NAND gate. We have two input symbols, A and B, and we get the output. Functional specification. If A and B equal to 1, then output is equal to 0, else output is equal to 1. Now we discuss about the HDL. What is HDL? HDL basically means the hardware description language. It is used to build the gates, simply known as the textual representation of the gate diagram. HDL, what is HDL? It means the simple representation of the gate diagram. The steps required to implement from requirements to implementation. Now we'll see here the steps that we required to know from the requirements to the implementation part. First of all, we need to draw the basic gate diagram on the truth table. For this, you can get the general idea about the gate functionality. Then we can design the required gate diagram, then write the HDL code to implement the logic gate. Now, some of the common HDLs are pre-HDL and Verilog. Verilog, it is one of the most powerful HDL form. Implementing HDL codes using hardware simulator tools. These are the steps for implementing HDL codes. Write the HDL program, load the program into the hardware simulator tool to the code, enter the values, zeros and ones into the chip input pins, evaluate the chip's logic and result is output. First of all, we write the HDL code and load it into the hardware simulator tool. And we will input the values, that is zeros and ones, Boolean values, to test the chip's logic. Then the chip's logic will be evaluated by the hardware simulator tool and the results will be obtained. Now, this is the hardware simulator tool basic diagram. Hardware simulator tool will be like this. Here are the two dots can be represented using to manipulate the input pins. And this calculator symbol is used to evaluate the chip's logic. And this screen is known as the output pin screen. Here is the HDL code. Whichever we load into the screen, it will be displayed here. And here is the internal pins. Here are the internal pins. Now, project 1. The basic project 1, we are going to build the logic gates. That is NAND, NOR, AND, mux, and simulate in three ways: interactive way, script based, and with or without comparison files. Now we'll move on to the. This is the hardware simulator. Here is the input pins that are displayed, and here are the output pins that can be displayed. Here are the internal pins that is inside the gates and HDL program. We can load the HDL program by just clicking on the button, and then we can load the load script or test script, and known as test script because we are going to test the logic of the HDL program, and we can load the test script. Then we can run the program by clicking the run. Now, first of all, let's load the basic elementary programs like AND. Let's load the AND program. Here AND program is loaded into the file. Now, let's load the test script of AND. Here the test script of AND is loaded. Now let's run the program. Here the program is being executed. So now let's see the output. Here the output has been displayed, and now let's see the truth table of the AND gate. Here the truth table is displayed. As we know that when both the input values are 1, we'll get 1 in the AND gate. It is the truth table for AND gate. Now let's see, or so let's load the HDL code for all. Here the OR HDL code has been loaded into the program screen, and then load script of OR is loaded, and then we run the load script. And it has been successfully run. Now let's see the output. Output has been verified, and now truth table of OR gate is displayed. So we got, as we know, when both the input values are 0, we'll get 0 in the OR gate. So it is displayed here. Now let's get the lost elementary gates, which are basic elementary gates. That is not gate, not HDL code has been loaded into the system. Now let's load the not test code. Not test script has been loaded. Now let's run the program. Program has been successfully run. Now let's see the output. So now let's compare. So if we give 0 as an input, we'll get 1 as output, and 1 as an input, we'll get 0 as output. This is what not gives. Now all the elementary operations have been performed. Now let's go to dmux, which is known as composite gate. Now load the dmux script. Now run the script. So test the logic. After the script has been run, let's go to output. It is output, and here is a dmux truth table. In a similar way, we can execute all other things. We'll check for XOR, which is the elementary gate. We'll load the script for XOR. Here the script for XOR has been loaded. Now let's run the script. Here the script has been running. Script after the script has been run, let's check the output and then compare the output. Here is the output for the XORs. In this way, we can run any of the HDL codes that we've written here and get the load scripts and test the code. This is my project 1. Signing off. Be visuality. Thank you.